Hello, Shorthand Tom here. In my engine videos, I speak of machining rough castings using a lathe and a milling machine. This is a milling machine. It is a sturdy drill press with a movable table. The table can be moved in both horizontal dimensions using these hand wheels. Both hand wheels have dials marked in 1/1000th of an inch increments. The dials have numbers 0 to 100, so each full turn moves the table 1/10 of an inch. In the vertical dimension, the milling machine chuck can be advanced in 1/1000th of an inch increments using this hand wheel. My video will show you how a rough casting is surface drilled, threaded, and fit together. It shows how to make a fine flat surface on uneven sand cast metal. It shows how to locate assembly holes and screw positions exactly and easily. It shows how to thread a tap hole without breaking the tap. It shows how parts are made to fit together perfectly in assemblies. And I hope you will enjoy watching the machining of the 1880s steam drilling engine frame. I've mounted the engine frame casting to the milling machine table using T-bolts that look like this and that fit in the slots of the milling machine table, and wooden clamps that I made out of blocks of wood with holes drilled through them, and one metal clamp at the back. Now the drawings call for us to run the center line of the engine frame from the high center point here to a place at the center back here. And I've tapped on the sides of the casting and fussed with it until the pointer lines up at both ends when I move the milling machine table in a long direction without adjusting it in this direction. So I know that the center line of the frame casting is lined up with the long direction of travel of the milling machine table, that it's parallel. When I crank the milling machine to the back end of the engine frame and check with a small scale, I note that I'm centered at 11/16 and that the full width is 1 3/8 inches. And in fact, 11/16 is 1/2 of 1 3/8. 1 3/8 and 16ths would be 22/16, and we have 11/16, a half of that. And with my simple pointer I can see that I've adjusted the mounting so that I'm at the center line at the back end of the casting as well as at the front of the casting. I'm going to spot drill a little mark at this end of the frame to mark that center line, should I ever want to relocate the part on it. Now with that small spot there, I can relocate the part using a pointer or a conical edge finder. I don't know if you can see the spot, but there is a little spot right at the end of where the drill tip is there. I'm also going to mark the center line with a spot at the front end of the casting. And I'm choosing a place right here that can be seen both when the casting is sitting in a horizontal position as it is now, and when the whole casting is turned up 90 degrees upright, I'll still be able to see that spot that marks the center line and use it to locate. And here we've marked both ends of the frame casting now with a spot that indicates the center line runs through there. The drawings call for us to mill a 1/2 inch slot along here, centered on the frame center line, the one we marked. And we haven't moved from that position, so we're still on that center line. But there may not be enough metal at the back edge there for the mill to touch at a 1/2 inch wide. So I may have to make the slot wider by a few thousandths, but still within tolerance, and then take the equal amount from this side so that the part will still remain centered, and adjust the width of the part that will slide in there by a few thousandths of an inch. But first we'll see. Now I'm going to mill a slot with a 1/2 inch wide mill, centered on the center line of the casting. No cut yet. Go a little deeper. Here's our first cut. We've passed the 1/2 inch mill through the area that's supposed to be the slot, and we haven't touched the back edge very much. So I'm going to shift the part forward to touch the mill a couple of thousandths at a time until we clean up that edge, and then I'll take the equal amount off the other side so that the slot is still centered, and I'll still be within a 1/64 of an inch of the stated 1/2 inch width. I've cleaned up the back edge by offsetting the mill by 8 thousandths of an inch by taking an additional 8 thousandths. Now I'm going to have to take an additional 8 thousandths off this front rail here, and that will make me a 1/64 of an inch over, and I'll call it okay. I'll make the part that slides in there 8 thousandths wider on each side to fit it. And here we're going to take the final 2 thousandths extra off the front rail. And that completes the milling of that slot. And here we're going to take the final 2 thousandths extra off the front rail. And that completes the milling of that slot. Now we're going to clean up this edge of the frame casting with a small end mill. And that will make it parallel to this slot and to the center line of the casting, and that will make this a reference surface useful in future setups. Here we go with milling a reference surface that's parallel to the center line of the engine. And then we have a clean surface that's parallel to the slot down the center of the casting and to the center line of the casting. Now, anytime we want to drill through the casting at right angles to the center line, we can simply rest the part on a 1, 2, 3 block on that edge. A 1, 2, 3 block is just a block of steel. And we know that if we drill, we're drilling through at right angles, and we'll use that when we go to drill through for where the crankshaft goes through at right angles, goes to the casting. I'm going to do the far edge that you can't see the same exact way, but I won't do that on camera because you can't see it anyway, really, and it's the same thing for the same reason. Now I'm going to mill a reference surface at this end of the frame casting, which is at right angles to the center line of the engine. Goes this way, center line goes that way. And that reference edge will be useful whenever we want to drill parallel to the center line of the engine. We can simply rest the frame casting on that edge and clamp it to a plate and know that we're drilling parallel to the center line of the engine. Here we go with milling a clean surface at this end of the engine frame. It will be a reference surface at right angles to the center line of the engine. I think maybe a couple more thousands, one more pass. And one more little one. And there we have a clean reference surface that is at right angles to the center line running through the frame and at right angles to the slot milled along that center line. Now I'm going to clean up the front edge of the frame casting the same way. And now we have clean reference edges on all four sides of the engine frame. Now I'm going to clean up the boss on the frame casting that receives the piston rod packing gland. And I'm using a 3/16 mil just to clean up a clean slot and a clean surface on this boss here. And I'll give it a couple thousandths. And just clean up that boss. It doesn't take much. Just to give that a nice surface. And I think I'm going to call that done. Now I'm going to mill the frame rails with an end mill until they're 1.25 inches above the base of the frame. And right now they're 1 5/16 above the base of the frame, so there's a 1/16 of an inch that needs to be taken off. And that will take a handful of cuts, so I won't show you them all, but I'll show you the ones at the beginning, some in the middle, and some at the end. Here we go with milling the frame rails. And when I get to the end, I'm going to go over and do the other rail. And over the other rail, back down. And I'll check it again. Never hurts to check too many times. No such thing. Okay, and what do we have now? Well, there's 1.25 inches. I still see another perhaps 20 thousandths more to go. I think there's another 20 thousandths left there to take off. So I'll take another 10. Okay, we still have a little bit more to go, and I'll show you when we're all done. So there we've completed planing of the frame rails. And here we have a closer look at the completed frame rails, and they're nice and smooth. I'm going to clean up the inside of the area that will be the bearing to make it parallel to the center line of the engine, and I'll show you when I'm done. I'll show you a few passes of cleaning up the area that will be the bearing for the crankshaft. And that'll do it for that side until we get the bearing caps on. You don't want to take too much metal yet. I want to leave it a little bit big so that when I put the bearing caps on I can mill it again to make the two edges even with each other. Next I'm going to clean up the edge of the bearing support area here a little bit with a mill, and I'll make about an 1/8 inch high of brightness there, just to have a surface that's parallel to the center line of the engine, which may be useful in later setups. Here we go with cleaning up the edge of the bearing support area. And that does it for that side. I'll clean up the other side too. Here I'm locating where to drill one of the mounting holes for the engine frame using a piece of rod. Spot drilling frame mounting hole number 1. Now we'll drill the first frame mounting hole with a 1/8 inch bit. And there we've drilled the first frame mounting hole. Now we're locating where to drill frame mounting hole number 2 using a piece of metal rod. Spot drilling frame mounting hole number 2. Now we're going to drill mounting hole number 2 with a 1/8 inch bit. And there we have frame mounting hole number 2. Locating where to drill frame mounting hole number 3 using a piece of metal rod. Spot drilling frame mounting hole number 3. Drilling frame mounting hole number 3 with the 1/8 inch bit. And there we've completed the first 3 frame mounting holes, and I'll do the other 3 at the back off camera because you won't be able to see them anyway. I've mounted the frame casting upright in the mill now on an angle plate using 3 bolts and clamps, just like when the part was mounted horizontally. And because this angle plate is a true angle plate, not too expensive but quite accurately true as a right angle, I know that my part is sitting at a right angle in this direction, in the forward backwards direction here. And because I milled a reference surface at the end of the casting here when the part was horizontally, that's at right angles to the center line of the engine that runs through here, I know that if I rested cleanly on this small plate that I have here of aluminum to protect the casting from scratching and things, that by sitting cleanly on that, that will cause the part to sit straight upright in this direction, in the where the clock goes direction, at a 90-degree angle here. And that means that anything that I drill will be drilled parallel to the center line of the engine. Anything I mill will be milled at right angles to the center line of the engine. Here we can see that the reference surface that we milled across the bottom of the castings, that's at right angles to the center line of the engine, we call it a reference surface, is sitting on an aluminum plate here on the milling table, and the plate just bridges the gaps in the table here. And because the casting is sitting cleanly on that surface, its reference surface, that guarantees that the part is sitting at a true right angle in the clock turning direction, in this direction. And because we've mounted the part to a plate that's at right angles to the milling machine surface in the other direction, we know that it's lined up in 2 directions, and therefore anything we drill or mill will be either parallel to or at right angles to the required axis. Now with a small square you can see that there's no light in there, no error, because that reference surface is quite accurate. And again, by the simple task of pressing down on the top of the casting a little bit with our finger pressure as we tighten the bolts, we can align that part just perfectly vertically. If you look carefully, you can see the spot that we drilled when we defined the center line of the engine when the part was mounted horizontally. And by aligning on that place with a simple pointer, we can locate onto the center line of the engine with the casting mounted vertically now. And we'll just check to see that that pointer points to that center dot that we drilled, and we're on the center line of the engine. I want to locate a place on the engine center line that's 1 3/8 inches from the base of the casting. And just to show you how you can do this quite accurately, I've used a conical tipped edge finder like this one to locate that back edge. It will look and feel like one piece when it's all lined up. Now certainly in the left or right there's nothing to stop it, so you just line that up with your fingers manually. But then you can feel to see if it feels like one piece front and back with the tip pressed against the base of the casting. And it does. And that means that the center of this tip that's 200 thousandths of an inch in diameter, the center is half that, the radius, it's 100 thousandths behind the edge of the casting. So we lift the tool away and we advance the dial, which is set to 0 now, one full turn to compensate for the width of that measuring tool. And now the center of the milling machine collet is at the very edge of this metal, within 1/1000, perhaps at most 2/1000 of an inch. And I want to go 1 inch and 3/8 in this direction. So that's 1 inch and 375 thousandths. That means there'll be 10 turns of the 100 thousandths dial to get 1 inch, and then 3 more to get 1.3 inches, and then to the number 75. This mill has a convenient feature in the form of a stop that I can set and lock that limits how far the mill table can be moved in a certain direction. And by setting that up, I've set it up so that whenever I come back to there, I'm 1 inch and 3/8 from the base of the casting, that distance that I set up. And that will be useful in spot milling, where we're going to pass back and forth to that point using a fly cutter. The drawings call for us to spot mill a clean area at this end of the engine frame. And that's supposed to be 1 inch and 5/8 in diameter. And I've set up a fly cutter to trace a circle that's 1 inch and 5/8 in diameter. That's slightly larger than the 1.5 inch width of the frame casting here. It's very important that our first cut with the fly cutter not be too deep. The metal here is sloped, and back here is where the metal is highest. And we don't want to catch that cutter with too heavy a cut that might tip the part, making the cut even heavier and gouge and damage this casting. So I'm going to turn the mill pulley by hand. The mill is unplugged for safety, to get us over to where that metal is at its highest, and make sure that we just about touch or don't touch there. And I'll advance the cutter by 1/1000 of an inch at a time until we are touching. And that way I don't start off with a cut that's too heavy. I'll just, when I'm actually running the machine, advance and move the cutter down 1/1000 of an inch at a time until we start to take some cut as we pass it back and forth. I've checked that the cutter seems to be working well by turning the mill pulley up above by hand with the machine unplugged for safety. And it looks like we're set up to mill that spot that's 1 inch and 5/8 in diameter here. So here we go with doing some spot milling. Now I'm only advancing 1/1000 at a time. I possibly could do a couple, but I just want to be very gentle to this. You can see how that spot mill is developing there. This is going to take a while, so I'm going to do some off camera and show you when we're a little nearer to the end here. Here we've milled about half the spot clean, and I'll show you a few more cuts at this stage. So I'll advance by a couple of thousandths of an inch and feed the tool. Here the spot is milled about 3/4 of the way across, and I'll show you a few more cuts that we're taking at this stage of milling the spot. One more. And I'll show you again where we're just about done. Now I'm going to take the last couple of high-speed finishing cuts on the spot mill. And there's a nice finish on that now. I'll get you in a little while to get a better look at that finish. But I'm going to call that done because I see a nice flat surface all the way out to that edge there. I could perhaps go a little more, but there'll always be a little bit of taper on that edge. But I have a nice flat spot that will mount the inboard cylinder head and the cylinder to. There you can see the nice finish with a little bit of mirror to it that the fly cutter has produced for the spot mill area at the end of the frame casting where the inboard cylinder head and the cylinder will attach. In order to get that nice finish, I had to use a newly sharpened bit and a high speed. Some of my earlier cuts, the bit wasn't that sharp and the finish was a little bit rough. But for the final cuts, I used a new bit and I increased the speed and it produced a nice finish. 3. There you can see what a nice finish the fly cutter will make at a high speed with a sharp bit. Some of the earlier cuts I made were made with a somewhat dull bit and they left a rough finish, which was okay at the start. But to give a good final finish on it, I sharpened up a new bit